All right, well, I'm the next speaker, and Dr. Randy Martin from Utah State University. I've been saying University of Utah all day long, up in Logan, and I'm going to talk a little bit about some automobile emission study we've done. Some of this, I'm going to summarize some of the older work, and I'll bring in some of the newer work we've done in the past. A lot of work, there are comments we've been getting on what does it matter? What do my individual emissions matter? In particular, when I idle or when I start my car. And so I'm going to tell you about some studies we've done. This is actually a summation of several studies. My co-authors, myself, Clay Woods, one of our graduate students, Dr. Abdelhalim Khadar from Nablus University, who spent the summer with us, and Joe Thomas from DAQ and Weber State. So, first of all, as you all know, automobiles, mobile sources, are a huge part of the problem. These are some graphs from the DAQ over the years showing that as time has gone on, the mobile sources have been pretty consistent at being about 50% of the estimated emissions of most of our pollutants. Even though the total number has gone down, the fractions remain roughly the same. So it's something we need to be aware of and be ready to control it as is required. So much like other states, Utah is focused on mobile sources as part of their air quality control scenarios, including emissions inspection programs, anti-idling programs, driving modification and outreach programs, basically education programs that you can get on the utah.gov website. However, a lot of these recommended scenarios aren't based in strong literature and research. It's kind of intuitive. And so that's what a lot of these research projects we've done in the past have been. Just in summary, these are a lot of the projects we've involved with over the years. We originally started by doing an on-road emissions study, looking at a lot of vehicles in the Cache Valley to see how many would or would not pass an IM program. We've done tailpipe on-road studies of buses versus cars, versus diesel buses, versus hybrid buses, versus CNG buses. We've done a cold start, hot start, idle study. We've more recently done a driver characteristics study, which I'll tell you about today. And just recently, as a part of a lab class, we've looked at what the pollution is inside of the cab of a vehicle compared to the ambient air. Are you protected inside your car or not? So just in summary, the on-road vehicle emission study back in 2004, we shot a laser across the roadway and had cars drive through it. And we could detect through IR and UV absorption, CO, NOx, and hydrocarbons. We also got information on vehicle speed, acceleration, and we recorded the license plate information, which when everybody hears that, they jump, oh my, there goes our privacy. But the idea was to get vehicle make and model and age. And so just in summary, don't have to pay too much attention to this, the numbers here, but what we found, and this is typical around the country, that a small fraction of the fleet is responsible for a large portion of the emissions. I was just at a conference earlier part of this week in Long Beach where these type of studies are still going on. There's some wonderful 20-year data sets involving these type of studies, and that fraction of vehicles is going down now. It's not 5 and 10% anymore. It's 3 and 1% that are the high emitters. So this is showing you the value of these type programs. And this type program was really one of the main forces in getting an IM program up in the Cache Valley. Another study we did up there was basically look, is mass transit a good thing? And so we did tailpipe studies of buses versus cars, and again, different types of buses, to see how many people you have to put on a bus to see if you get parity in air emissions. And the first time we did that, you see the first two lines in that graph, you had to put a lot of people on buses, the older type buses, diesel buses, CNG buses, in order to equal the emissions that you were emitting from your cars. So for example, that first column, first row there, 21 people had to ride a diesel bus in order to have the same amount of NOx emissions. When we redid the study back in 2011, you can see you put one person on the bus and you make a gain in your total emissions for NOx, CO, and hydrocarbon. To get to our idle studies. I presented this at a lot of different places, but this was done in cooperation with ourselves and Weber State. And what we basically did, we looked at A cold start, which means the vehicle has been off for 12 hours, so basically overnight. What are the emissions when you start it then? We looked at the hot starts, which means you drive somewhere, shut it off, and then restart it after 5, 10, or 20 minutes. And then we also compared that to 5, 10, and 20-minute idles. Now, I show this up here, a little perspective, a couple of little data points I pulled out. We did a survey just around Logan, and it shows you where the percentage of people that were idling at all those places. And it stuns me. I hate to say it, but the higher education area was the highest rate of idling. We should know better, but we don't. There were several reports, and there were some from this winter too, in the newspaper and on KSL, about identified idling. The police mentioned that it was an easy target for thieves, and we actually had our first 2 in Logan this last year. One of them was a donut truck, of all things, that the police had to track down. And then, like the last one, 600 cars unattended in just 2.5 hours. That's incredible. I think we ought to write into code, if you leave your car idling, it should be a free car. That would be the ultimate penalty. So we essentially answered 2 questions. If you have a cold start, how long should you let your car warm up? And so we sampled over 60 cars over lots of different cold temperatures. And it basically comes down to this. This is the average curve that we saw. When you start your car up, you see a very high emission within 10, 20, 30 seconds, and then it drops off very rapidly. And by the time you're out 2 or 3 minutes, your car, from an emission standpoint, is totally fine. And the mechanics will tell you you don't need to warm it up beyond that either. So we've got this little rule of thumb, 1 to 3 minutes. I tell my kids, my students, start your car, scrape the windows, and go. And it's actually going to behave better because you're going to heat up the catalytic converter faster by driving it anyway. So you don't need to warm up your car at all. And then in talking with people this week out at the emissions conference, generally it's assumed that about 65% of your car's total emissions can come from that cold start phase. So the more you can do to minimize that, the better off you are. The second part of that question is, during a short stop, I go to 7-Eleven, want to go in and get a cup of coffee or a big gulp. Should I shut my car off or should I let it idle? Well, here are the results. The magenta columns there represent what the emissions look like if you shut your car off. The orange lines look like if you were to let it idle for that 5, 10, or 20 minutes. And you can see across the board, don't let your car idle from an air pollution standpoint or from a theft standpoint. Not a good thing. And so here's some of the numbers. And the rule of thumb that we just suggest is if you put your car in park, shut it off. It's not saying to shut it off at stoplights. I'll tell you some more about some idle emissions in a little bit here, and some of the stuff I learned this last week. But there's no reason from an air pollution standpoint that your car should ever be idling. This summer we did this Onroad driver gender study, and basically what we did, we drove the same vehicle, which was a 2001 Dodge Ram, over a same course, 5.7 miles, and included lots of speed changes in various grades. And we had 4 categories of drivers with 5 subjects each, male versus female, older drivers versus younger drivers, and we rated that by years of experience of driving. And the results, you can see that, I guess, okay. This shows you male versus female for NOx and hydrocarbons. So look at the females. Lower in both cases. Now the results, we're still working on the statistics. They're not significantly different at the 99% confidence interval, but we're sorting out which level they are significant at right now. So chalk one up for the females. We look at older and younger. So here's the younger drivers tend to be cleaner than the older drivers for both NOx and hydrocarbons. Again, somewhat non-intuitive. So what happens if we combine all that data? Well, that's what I told you about the analysis. So we combine all the data, and so what you're looking at here is young male, young female, experienced male, experienced female. Looky here. The inexperienced, youthful females all appear to be the winners as far as the lowest pollution emitters, which was really odd because when you drove in the car with them, they were also the most talkative. I don't think they ever shut up. And I just hypothesized that the older males were kind of set in our ways, and by God, nobody's going to tell us what to do. But I will tell you that 2 of the different experienced females told me they knew the route that we drove explicitly, and they knew where all the cops hung out, so they drove more carefully than they would drive in their normal driving situation. So these data are interesting and tantalizing, and we're still doing the statistics on it. So more to come on exactly where this is going to fall out. So the question has come up to me, where do all the emissions throughout a drive cycle, throughout a day's experience come from? And in other words, what fraction of your total emissions come from your cold start, from your driving, from your hot starts, from your idling? And the EPA MOVES model, this is something I just learned this weekend, this week, they do not account for idling within the model. It's hard to. How do we know how long anybody idles? You really don't. But they're trying to look at that. That's something they're going to be looking at recently. But I just decided to say, I'll look at the extremes based on our studies. So I used our data from USU Weber State studies. And so I know from other studies that in Cache Valley, typical people drive 27 miles per day, and they have 11 stops. And so I said, okay, in those 27 miles, I could estimate the hydrocarbon, the NOx, and the CO total emissions by looking at that gender study. What were our total emissions across everybody throughout that drive? And then I multiply it to 27 miles. For the 11 starts or idles, I assumed we had 1 cold start, so all the cold starts were the same, and that was the average of all the data we did. And then I assumed that we had 4 5-minute hot starts or 4 5-minute idles, 3 10-minute hot starts or 3 10-minute idles, and then same for 20 minutes. That gives us 11 stops, a cold start, and the 27 miles. And when you do that, these are what you get. So the figures on the left are the assuming all hot starts. The figures on the right are assuming instead of hot starts, you're leaving the car idle. And as you can see, in every case, when you idle, you increase your pollutants significantly. Depending on the pollutant, anywhere between 158 to 26% increase, just accounting for your idle. And I've just got it bracketed out where it all fell out. I've got a slide on the next picture. So if we go back to that 2014 estimates of total emissions, look at the mobile source, how can I make pie slices of that red piece? By looking at the cold start, the driving, and either the idles or the hot starts. So the best case, all hot starts, that gets broken up as here. Cold starts responsible for 19%, dry cycle 15%, and all the hot starts 14% of the total. So it's kind of pretty much equal of all the slices of the pie if everything is hot starts. If you look at the worst case scenario, which would be all idles and no hot starts, a much larger slice becomes from the idles. So the idles can be significant. So as I was flying back from Long Beach last night, I thought, well, does this really mean anything? Are all our mobile sources automobiles? And the answer is no. According to Joe Thomas from DAQ and Weber State, actually heavy-duty vehicles make up about 60% of our total mobile sources. And so I did all these calculations to see how this fraction that I calculate out compared to this 320. And if we have an average per car daily emissions of 74.8 grams for all the pollutants, and that assumes half hot starts, half idles, and we have 1.57 million vehicles in the Wasatch Front and Cache Valley airshed, we come out with 130 tons per day of pollutants, which fortuitously is about 40% of the 320. So we're kind of close, luckily close, I think. Like I say, we do not include the high-density vehicles, and I don't have the trip characteristics for the Wasatch Front, but it's in the ballpark, so it's kind of reasonable to assume. So now we just have to figure out exactly how much time people spend idling. And I've got 37 seconds to tell you about this. This was a driver pollutant exposure study. Part of our ABET accreditation for engineering is we have to have the students design an experiment within the lab class. And so I had them design this. I said, what do you want them to do with carbon monoxide? I said, let's measure what's inside the cab. So we took my truck, 2007 Dodge Ram, just like John said, we all test our own houses. I also test my own truck a lot. And we drove up and down Main Street during rush hour and late at night. And we did it in triplicate. And we had 3 scenarios: windows open, windows closed, windows open, vents open, windows closed, vents closed. And then we randomly selected whether we were going to be sampling inside or outside. I originally had 3 CO monitors, and 2 of them died while we were calibrating them, so I ended up with 1. So we had to do either inside or outside and alternate them. And so here you see the results. Windows closed, vents open up in the upper left. Windows open, vents closed in the right, and then windows open down here. It says windows up, windows open over here. And you can see if you look at the statistics, they're all pretty much the same, and the concentrations are all very low, whether you're inside or outside the car, less than 2 parts per million. And the highest variability seemed to be outside. If you look at the error bars, there was one case where they were statistically different. And if you look over there in the lower left-hand side, that's when the windows were closed and the vents were closed. So we basically captured the air inside the car, and it stayed there. We apparently got a big gulp, not a big gulp, 2 parts per million of methane when we rolled the windows up, and it just stayed there. And to give you an idea of that, you see it here. That red line is 2 different cases, although they're lower concentration, with the windows up and the vents closed. And it just stayed consistent all across the transect, as the other ones were highly variable. So when your windows, and you all know this, when your windows are up and the vents closed, it gets stuffy in your car. So here's a measure of that exactly. Summary, well, just repeats everything I've just said. One thing I will point out down here is we do have a PDF poster available of our anti-idling study. So if anybody wants that, send me an email and I'll send that to you. And you can use that for whatever propaganda you want. With that, questions? Got about time for 1 or 2. Terry.